Another important concept to do the real numbers chapter is the fundamental theorem of arithmetic. The fundamental theorem of arithmetic. Now, although the name sounds long, it's kind of easy. And we've done this in our earlier classes. It basically states that every composite number. Now, what's a composite number? We know that a unique number is 1, as it's neither prime nor composite. So, unique number 1. And a prime number are numbers whose prime factors is 1 and whose factors are the 1 and number itself. Example is, if we take 2, it's a prime factor. Its factors are 1 and 2. The numbers which it is divisible by. If we take 7, the prime factors of 7 is also 1 and 7. Therefore, prime factors are numbers whose factors are the 1 and the number itself. And then their composite number. Now, this is where the fundamental theorem of arithmetic comes up. Composite numbers are numbers which can be expressed as a product of its prime factors. So, if we take 4 for example, 4 can be expressed as 2 into 2, which is a product of its prime factors. We take 36 for example, it gives us 6. We can break it down into 6 into 6, and 6 can be expressed as 2 into 3, 2 into 3. Therefore, 36 can be expressed as 2 into 3 into 2 into 3, which is a product of its prime factors. That's the fundamental theorem of arithmetic. It states that every composite number can be expressed as a product of its prime factors. And now, using this, we can find the LCM of a number. We have done LCM in our earlier classes. Now, we'll take two numbers, 6 and 20. Now, most of you might remember this, but if you don't, here's a quick explanation. We have 6 and 20. Place the lowest prime factor which both of them are divisible by. In this case, it would be 2, and then divide them. This would be 3, and this would give us 10. Now, 3 is a prime factor, hence write 3 on the left hand side. So 3 by 3 would be 1, and this would still be 10, as 10 is not divisible by 3. And now again take a 2. This would give us 1, this would give us 5, and then take the 5. Once you get 1, just keep writing down 1. This would give us 1 and 1 until you have 2 1s. Therefore, the LCM of 6 and 20 would be 2 into 3 into 2 into 5, which would give us 60. That's how you find the LCM using fundamental theorem of arithmetic. Now, having LCM 60, sometimes they might ask, find the HCF. Now, you can either use Euclid's division lemma to find the HCF of these two numbers, which we have done in the previous video, or there's another identity which is very important for this exercise. This identity states that the HCF of a number to a pair of numbers into its LCM would be equal to the one of the numbers and the other of the numbers. Example, HCF of 6 comma 20 into the LCM of 6 comma 20 would equal one of the numbers, which is 6, and the other of the numbers, which is 20. This gives us 60, which gives us the LCM of a number, which is 60, and the HCF, which we would get as 2, would be equal to one of the numbers into the other of the numbers. Both give us 120. 120 is equal to 120. This is a very important concept. I'll repeat it again. The HCF and LCM of a pair of numbers would be equal to the product of both of those numbers. It's very important. You will need it for majority of the questions this chapter.